So hello guys, we are Team RaceForge. I'm Avichal and he's Darshveer, and we built a total Toyota GR live race in which we simulated the IMSA GTD plus GTD Pro, which is a part of Toyota GR races. Now we built this entire track using splines, and it captures all the features that are there in a track, including chicanes, the hairpin, and also the straights. This was built using curvatures and speed vectors, which is built on spline and uses interpolation to get the exact position of the current drivers. We used 20 drivers in this. Now let us start the simulation. So in this simulation, we have different kinds of speed in which we can see the simulation happening: 0.5x, 1x, 2x, and 5x as well. Now we also try to mimic a 3D model for this, in which we can see the simulation happening in 3D. Now you can see these cars are running in 3D right now, and along with that, now let us close this 3D model and look at the simulation happening. So we simulated everything from physics to tire wear to weather to wind speed and direction, pit stops, tire strategies, and fuel consumption and refill using the models and data, using the data sets that were provided by the hackathon organizers. Now I'll hand over to Dashvi to explain how this happened.
So basically, we simulated multiple factors, as Mitchell already told. Some of the factors included tire degradation, which was derived from the CSV, analysis endurance with sections, which was present in almost all the races. We took degradation as a delta of lap time over which how it changed over each lap. Then there are grip limits and traction circles. We use the telemetry data.csv to calculate lateral G forces and longitudinal G forces to define a friction circle. Then we just calculate the grip by a summation of mechanical grip plus aerodynamic coefficient into the square of velocity. Then there are other factors like which we said earlier in the starting of the race, which are wind speed, weather, rain, etc. The cornering speed at apex is reduced due to wind direction at the hairpin. There are error in pit stops. We also noticed for the tire to have optimal grip, the track temperatures must be between 30 and 50 degrees Celsius, and thus added a factor to reduce the tire grip if the temps were leave the thus told range. Rain causes temperature cooling, temps to drop, and the drivers switch to wet tires for better traction. The driver levels are also emulated to be as close as to real. So all drivers are not of the same caliber as in a real life race would be. And there is also front and rear brake biases included. The formula were derived from telemetry data, weather CSV, and the endurance with sections CSV. Now let's skip forward to the end of this.
Yeah, so I will skip forward to 5x to get the simulation done quickly.
We also run undercut analysis, which is basically the difference in pit stop strategies, which lead to a real life positional change among the drivers. Now that we can see, the optimal pit stop strategy has also been generated using a decision tree classifier. It is suggested the driver as a one-stop strategy and two-stop strategy based on confidence, and the optimum tire compounds which should be used, and optimal pit windows where these tire compounds should be switched on. And now I'll switch back to Avichal to continue with the ML insights.
Okay, so while this ML insights is being generated, so we recorded all the logs from where the driver was overtaken by someone, from where he did pit stop, where he did fuel refill, everything, and we fed that into an ML model and got some results. And after that, we took those results and conveyed it to a LLM, and we got this beautiful looking thing where we get insights on where the driver can improve and what his performance is, how his strategy is, how his execution is, etc. So this was our project, and I hope you really liked it.
Thank you.
Thank you.